Okay, today we're talking about rational expressions with unlike denominators. What was 12-5 about? Yeah, the whole thing was, everything was the same except it had like. Today we're talking about unlike. So we have to talk about this concept, least common multiple, LCM. Now, can anyone tell me, just like in simple words, what's LCM? What's the least common multiple? Try your best to give it to us like in everyday student-to-student terms. Benson? What's least common multiple?
Number that can come out of two numbers. The smallest number I can't not use multiple.
Oh, you can use multiple.
Okay.
Yeah.
Smallest multiple out of two numbers.
Josh, I'll give you.
It's like the smallest.
Uh-huh.
Well, it's the least common multiple.
Oh. Okay, the way to define least common multiple, it's the least common multiple of two or more numbers. And really all this right here is another way of saying that. But you do need to understand what the word multiple is. So let me give you a number. 2. What's the first multiple of 2? Be very careful. 0. Because 2 times 0 equals 0. What's the first one you thought of? 2. Because 2 times 1 equals 2. What's the second or third multiple of 2? 4. Next multiple? 6, 8, 10, 12. All right, another number, 10. 10, what's the first multiple? 0. What's the second multiple? 10, 20, 30, 40. Okay, a lot of people do this, guys. A lot of people do this. They mix up least common multiple with, what's that other concept? Greatest common factor. That's very easy to do. And I do this. This is kind of often. You don't have to put this down if you're not confused with it. But I deal with 2 numbers, 3 numbers, 4 numbers. The least common multiple is either going to be one of the numbers or something above them. Okay? The least common multiple is usually one of the numbers or above them. The greatest common factor could be one of the numbers or below the GCF. So when I say the LCM of 2 numbers, I'm talking about either one of those numbers or something above it. GCF, either one of those numbers or below it. Okay. Let's look at a couple numbers and see if we can figure out what the LCM is. Yes, sir. Yeah, go ahead. Okay. You thought it through? You can ask the question if you want to, but like maybe you're thinking it through, you got your answer.
Couldn't the GCF be below it? The GCF is 0.
The GCF? Yeah. The GCF is never 0.
LCM.
Yeah. So I guess that would be the only. But, well, actually, yeah.
Where's like a GCF? It was like negative something?
No. Once you get the negatives, we're talking something else. Yeah, so positive numbers. And how about that? With positive numbers, not even 0. We're not even thinking 0. So let me give you a hint. Your GCF is never going to be 0 on these problems, and your LCM is never going to be 0, just so you're not like confused about that. But that's a good question, good thought. Okay, find the LCM of these 3 numbers. So can it be smaller than 12? Can the LCM of these 3 numbers be smaller? Can it be smaller than 2? Can it be smaller than 30?
Yes.
No. Can it be 30?
Yeah.
Can it be anything above 30?
Yeah.
Okay, so some of you could do this in your head. Great. There's that method. If you just know the LCM, just come and get it. If you don't know what it is, there's another way which we really want to get a hold of. All right, what's the LCM of the 3 numbers? 60. How many of you kind of looked at the numbers and you thought, okay, it's not 30, but what's the next multiple of 30? 60, and you knew all of them fit into 60, and that's it. 60 is the answer. LCM is 60. But for some of you, maybe you're still wondering, how in the world how do you get that? What you want to do with these 3 numbers is you want to get the prime factorization. We'll do that real quick. What's the prime factorization of 2? Yeah, this is 2. 2 is the prime factorization of 2. What's the prime factorization of 12? 2 times 2 times 3. And what's the prime factorization of 30?
3 times 2, or 2 times 3 is 9.
Yeah, it's good to go in order because it helps you to keep things organized and easy to pick out. Okay, this next concept this next statement I'm going to make it several other times, and I'm going to actually write it up there so that you're not confused on how to do it on your own. If I want to find the LCM of these three numbers using prime factorization, I have to use each one of the prime factors the greatest number of times it's used in any one of the factorizations. That's a hard statement. This is what I mean. I'm going to use 2, but I'm going to use 2 how many times? Twice, because how many times is 2 used in the first number? In the second number? In the third number? So how many times is it used the most? Twice. So we would say 2 times. 3, how many times is it used the most? Once. And 5? Once. And again, I'll write that note down so that you're like, okay, I could do this on my own. What's 2 times 2 times 3 times 5? That is 16. Bless you. Now, if you can get the LCM in your head, go ahead and do it. That's fine. I'm okay with that. But if you don't know how to do it, and you will have bigger numbers and more difficult numbers, prime factorization will get you there anyway. So, can you use prime factorization on every single one of them? Yes. Can you use your head on only your head, just head knowledge and what you know on every single one of them? You could, but really, there's a limit to everyone here. And prime factorization, fortunately, does not have a limit. All right, here's the note I want you to get. Use each prime number, or prime factor, I'll call it, the greatest number of times. And I think that might confuse people. Greatest, isn't that greatest common factor? Okay, greatest is in both, but this is not talking about factor. Greatest factor is talking about greatest number of times. It appears in any of the factorizations. As I was making up my notes here, I was like, man, I'm spending a lot of time on LCM, like a lot. And there's a reason why. On these problems that we've done above this problem, or above this note, you don't really need them. Most of you are probably saying, I got it. That's fine. But the next problems, in just a couple problems, you're going to see this concept of using each prime factor the greatest number of times. That's going to help me out with more difficult expressions. So let's just get review with example number 1. So go ahead and look at example 1 and find the LCM of 15a squared b squared and 24a squared b. Okay, check to make sure, especially my numerical factors are good. So does 3 and 5 get me 15?
Yes.
And does 2 and 2, 2 and 3 get me 24? Okay, now I'm going to use each factor the greatest number of times it's in any one of the factorings or factorizations. So how many times am I going to use 2? How many times? 3 times. How many times am I going to use 3? 5? Okay. What about the variables? How many times am I going to use A? Twice. Because it's used twice in both of them in this case, so that's common. But then what about B? Twice, because it's used the most twice here. Only once over there. Okay, what is this value right here? Anyone know what this is worth? So simplify this. 120a squared b squared is the LCM. Now, be honest with me, and just take this as an honest question. How many of you got that in your head? The 15 and the 24 in your head? I mean, you could. I mean, if you really thought of it, you could do it. You got to be focused, and you get it. But it's tougher. How many of you can get it with the prime factorization pretty easily? Once you get those factorings, you get that number. Okay, so use that, especially these numbers are not huge, but they are a little bit harder to work with. How many of you get the LCM of two expressions here so far? Okay, this is really what I want you to do in today's lesson. You're going to do several problems like these, except they're not always that easy. Example number 2. It's our last example. Because this whole chapter is about rational expressions, we get x squared minus x minus 6 and x squared plus 2x minus 15. Let that soak in a little bit. You're like, what? These are both trinomials, and I want to find the LCM of two trinomials. I don't even know where to start with. I don't even know what to start with. It's not as simple as just looking at them and figuring it out. No, it's not. It's not even factored. It's not even factored. But can it be factored? Okay, can somebody tell me how to factor the first trinomial? I know x goes in the first blank. So does.
What equals negative?
Yeah, what multiplied gets me negative 6, and what added get
Negative 3 plus 2.
negative 3 plus 2. And here I'll check it. What's negative 3 times 2? Negative 6. What's negative 3 plus 2? Negative 1. That works. Good. Second set. I got my x's again. What are those two numbers that fit in with those x's?
Negative 3 and 5.
Negative 3. Is that what you're going to say, Benton?
Yes, sir.
Okay. What's negative 3 times 5? Negative 15. What's negative 3 plus 5? 2. All right. Great. I had the factorizations. Now what? Okay. It's the same question that I asked for the other problems. What are the prime factors, or what factors? And I'm going to use each one the greatest number of times in any one of the factorings or factorizations. So I'm going to use x minus 3. How many times should I use x minus 3? Once. It's used once here, it's used once there, the greatest number once. I'm going to use x plus 2 how many times? Once. Because it's used once here, no times there, greatest number once. Any other factors?
Yes.
X plus 5. X plus 5. Yep. That is also one of the factors. And thankfully, for my sake and your sake, you just circle this as your LCM. That's your LCM. So you don't have to. You could multiply it out, but don't multiply it out because it's pretty complicated, and it just takes longer when that is my answer.
Is it like a different, triple color?
One times 3.
Actually, what's going to happen? You're going to get FOIL here, right? You get FOIL here. What result do you normally get with a FOIL? You get a trinomial. So then you're going to do a trinomial by that. So you don't have to do that, and I would advise you not to. So to find the LCM of numbers, variables, or polynomials, don't you go through the same process? You want to factor it out, find the common factors, and list them out the greatest number of times. Okay, I want to make sure you guys are good on this. So on page 687, I want you to find on number, actually, just number 3. It says find the LCD. Okay, let me write this last note and then I'll let you do that problem. LCD. That stands for least common denominator. Okay? Least common denominator. All that means is this. It's a deep little acronym for the LCM of the denominators. That's all it is. It's the LCM of the denominators. And we'll talk about this more tomorrow with you guys. We do. We'll have this tomorrow, and you won't have me on Friday. You'll have me back on Monday. I don't know. Oh, I don't like that either. What are you doing, Swivl?
Can you delete that? We don't have to.
Well, I gotta look at it. I mean, it depends on, were you ready for it? Does it capture the emotion when I write stuff down? I mean, I gotta find out. I can't just say no. Okay. LCD. Listen up carefully, guys. This is where I'll leave you here, and I want you to be able to do your homework well. The LCD, all it stands for is the LCM of the denominators, so least common denominator. And so on number 3, what are the denominators? X squared and X. What's the LCM of those two values? Yeah, your answer would have been X squared. That's it. That's all I wanted on that one. Okay, go ahead and do it with number 5. Number 5. So I want the LCD of those two fractions. So I want the LCM of 15m squared and 18mb squared. Okay, what's my final answer? This is not my final answer up here. Benton? 90 n squared b squared. So when you multiply this out, you can do 5 times 3 is 15, times 3 is 45, times 2 is 90, or times 3 is 6, times 3 is 18, times 5 is 90. Any way you do it, it's going to get you 90. Can I ask you this question here? How many multiples of a set of numbers are there? Infinite. You can get 90, 180, 360, 720, on and on and on and on. Why is the least common multiple the best, or why is it even something taught? Like, why do we really emphasize that? That's tomorrow's lesson. Okay. Okay, this is what I want you guys to do in just a moment. I want you, the instructions won't say it, but I'm telling you right now, on the problems I put on the board, I want you just to find the LCD of those fractions. That's all you have to do. LCD. Do you understand me?
Yes.
So, Mr. Ray, do we have to add it? I said find the LCD. That's it. 17 to 31 odd. 17 to 31 odd. I want LCDs. Harper? Like you have a question? Okay.